Hey, good morning, guys, and happy Easter on this beautiful day. Get this in here just a little bit better. All right, so this came back to me after about 6 months, and blowed actually another pill in it. However, one of the things that actually caused the whole problem was this little jewel right here. And apparently, which every so often, you'll get one that's actually in a weakened state, even brand new. The tab itself was actually cracked. So I think that's what actually caused the main problem with this. So we got you all brand new transistors in there. So we went ahead and replaced all 4 of them since we didn't have anything that was going to be comparable as far as on the HFE. So went ahead and replaced all 4 of them. That way we're good to go. Complete new batch. So, all taken care of there. So, I'll run through here real quick and give you up to date as far as some of the other changes that we made on the inside of this. That way, hopefully, whether it is that or something else, I think we're going to make sure that there's no hidden problems that could arise later in the future too that I'd seen. So one of the things that we did was we went ahead and redid the biasing. I know you just use this on AM, but since it's already biased, we might as well go ahead and take full advantage of the situation and keep it in there. So on the biasing, last time I did make a small modification, went back and redid it again and put it closer to the formula that I've been using myself over the last year or so. So what I did was we went ahead and reworked your biasing. I dropped the input voltage down on the bias a little bit. Went ahead and retuned the 4 pill. Just had to add about 15 puff on the input in order to go ahead and get that to lay down nice and flat. Wound up with some really good numbers as far as on the overall. So definitely impressed with that. Went ahead and put a small suppressor back here, and essentially what that does is this starts the the fall of the voltage that's coming into the system itself. I don't typically bias this format, but it does work. So instead of pulling it all out, changing out the relay, and going through an added expense that really wasn't necessary, we just went ahead and put a small, like I said, a small bump here to go ahead and essentially about a half a volt. Half a volt doesn't sound like much, but it is by the time we wind up all the way to the very end, which is going to the transformers. So small voltage bump here, and then we go up here and we've got another small voltage bump. This one here is nothing more than maybe 1/10 of a volt as far as on a drop going down. What this is this is just so that when the RF is coupled with the DC voltage in this format, sometimes you wind up with a little bit of a spike, and that's all this is for here. Just go ahead and make sure that you have a secondary bump that shunts any of the aspiratics directly to ground. So at this point, we have 13.8 volts, which is ideal for the system. And then I went ahead and put a couple other components in there that are used in my system of biasing in order to go ahead and keep it at a maintained voltage, which is a little bit lower than what the, if you will, the old style X-Force coupling is. It's great biasing as far as if we were still using Toshiba's, but with the HGs, they're not as forgiving on the input voltage for biasing. So we'll go through here and I'll show you real quick as far as what we've got on the biasing. Went ahead and also did a small little input bump as well. That way we could go ahead and actually put a small attenuator. And the only reason why there's a small amount of attenuation that I went ahead and added to the original is primarily because of the fact that the 22290s, when you're going into these, they're actually bumping the 4-pill pretty hard. So we went ahead and made a small little bump there. I've seen that there was some discoloration here with the original resistor. So, and I usually use about a 1.5 ohm, roughly, was what this drops down to whenever I'm all done. But you had a chip out of there, and it was a little brown. That could have been one of two things. It could have either been where the system's getting kind of overdrove here, or where your 4-pill is trying to back up into the 2-pill. So we wanted to go ahead and make sure that that was all taken care of. So that's all been changed out. We went ahead and replaced our output here. Apparently you get it shut down in plenty of time. This was a little brown, but wasn't actually bad, but we went ahead and replaced it anyways, as far as from the original one that was in there 6 months ago, mainly because it's a little dark and it's got a chip, which usually means that it's sustained a load due to the fact that we had one transistor that it went bad. So we replaced that. We went ahead and replaced all 4 of the 10 ohm resistors in there, and some of these, because it depends on which variety that you've got. On the feedbacks, find the other one in here. One of these was kind of discolored, which usually when it's discolored a little bit, oftentimes what it is you'll wind up with a short inside these. And some of these smaller ones like this, you actually wind up, when that happens, you'll actually wind up leaking voltage as far as your DC current. And that's all this is a DC block. But you'll actually wind up with a small amount of leakage that's actually going to wind up coming from the DC voltage that is setting at rest on the other side of the transistor on your collector side. You'll wind up with that leakage that's coming back into the input side. When that happens, what you do is you actually are essentially keeping the transistors on, so even when it's in the off state from not being keyed, the transistors are still trying to work. And long story short, you wind up burning them up. So that's all been taken care of. Shouldn't have a problem there. Good evening, Greg, or good morning, depending on your take on that. Yep, I've still got about another hour before I call it quits out here in the shop. So, anyways, let's get you guys some numbers here. I'm going to show a couple other things here as well. I've already got the analyzer set up here. Let me power this off and power it back on because it's been on for quite some time. That way I know it didn't pop out or turn off in the middle of what I'm trying to do. All right, so over here, okay, that way we're on a center frequency. So our little green caret is set right now on center frequency. We're going a total of 50 megahertz across the span on this one. We're also going to show on the other spectrum analyzer, I'll show you where we've got that one set at. This one doesn't have quite the overall bandwidth. It actually will go up to 5 megahertz as far as as far as on your overall span. So we're going to go ahead and utilize this one as well. That way we can see your smaller window. The other one we're going to use as far as on the wide window. So, all right, so let's start here. Oh, and for a different format for this test, we're actually going to be using one of our new President radios. I have not done a review on this radio as of yet. It is one that's going to be coming eventually. But we're actually going to be using the President Walker on this one. So, like I said, pretty impressed. You'll see why here in just a few minutes. Alrighty, so let's start here. Since we've got our camera, everything set up. Let's start with just the radio here. Okay, so that is principal. Hello, audio. So that way you can see that the radio is going in nice and clean to start with. We're going to go ahead and add amplifier. Hello, audio. Second, third harmonics coming up, which is great. And here on the KC901. Okay, so this is going to be covering a total of 50 megahertz. Principal signal is going to be 27205. Hello, audio. Okay, so everything that we've got is down about 70 dB as far as on the one. Let's find out where it's actually at. Which is at about 25 megahertz. And like I said, that's all the way down, so it's not even in the frequency range that we're even considering. So they're again not going to cause any problems. Alrighty, let's move this up there. Let's take a look inside here. Alright, so let's go around the band here. Alright, so we got a 5-watt slug in reverse going back to the radio, 5,000 watt, or excuse me, a 5-watt slug going back to the 5,000 watt per dummy load, 1,000 watt in peak, and 1,000 watt in average. That's what we're looking at. So I'll get you some numbers, and I'm also going to show some voltage references as well. So shut that off for a second, and I'm going to show you how much drive we're actually putting in here. Let's start by turning this around, see what our dead key is, which is about 3/4 of a watt. And at this current setting, that's as low as the radio that I've got will let me drop it down to. So we'll keep that in mind. Hello, does go over 5. All right, we'll turn that back around. That way you kind of see what the dead key is. Hello, 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 audio. Hello, audio. So just barely over what, 20 watts PEP. Hello, audio. And what, hello, audio. It's just so hard to actually see this. Pull this out here real quick. Let me grab 50 watt slug. Oh, you can see what our peak is. And I'll show you what the average is as well on the radio that we're using to drive it with right now. Hello, audio. Audio. So about 25 watts of drive on the PEP. We're going to go to the average. So still going to be looking at our center scale. Hello, audio. So about 14 on the RMS. So definitely got plenty of drive. All right, so let's put this back in there. Back in peak. Okay. Hello, audio. So about 900 on the R or on the PEP. Hello, audio. So 900 on PEP. Got what, 5? Audio, audio. About 550 on the RMS. Audio, audio. About 3/10 on the reflect coming back from the dummy load. Audio, audio. Yeah, about 3/10 on the input. So really good on that. Let's turn the variable all the way open on the radio or on the amplifier. Hello, 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 audio, audio. So 1,000 watts. Audio, audio. And about 610. So that was with the variable all the way down to start with, and that was with the variable all the way up. All right, so get the probes held here. We're going to show you what the our bias voltage is. Hello, audio. So about 0.3435. You know, it's going to vary based on your drive. So it's right about where we want to be at with the HGs. So it's going to give you a nice clean signal. You're going to be able to use it on the AM as well as on the sideband when you use the delay on the front. Preamp works nicely still. Okay. You guys can see the screen over there. All righty. Well, Mr. L, I'll tell you what, buddy. It's been a pleasure to do this for you. Hopefully you're going to get some long life and longevity out of this. Like I said, we went ahead and, like I said, put another small impedance bump in there. I'm not sure how hot your radio is driving it. Right now, between that and the Cobra 29, those are probably my 2 weakest radios that I have on the workbench. So, you know, I know that you've got some radios that are going to hit it a little bit harder. So in that particular case, I would probably run your variable back just a little bit to go ahead and give it a little bit more of an impedance bump. But other than that, you're ready to rock and roll, big guy. I'll go ahead and get this all boxed up probably tomorrow evening and give you a heads up as far as Monday, and then that way we can get this back to you. All right, guys, I appreciate it. Like I said, happy Easter again. Like I said, I've got another teardown that we're going to be working on that's coming up here in just a little bit, but I do have kind of an Easter special that we're going to be working on, and that'll be coming up after I get up this afternoon. So take care, everybody. Appreciate it again. Thanks for watching. God bless.